Today's the day for the most important decision of your life, choosing a thermally conductive adhesive. Luckily, I'll be here to guide you through the process. In this video, we're going to go over the 5 factors to choosing a thermally conductive adhesive. If you're interested in learning more about the types of thermally conductive adhesive, check out the article that's linked in the description below. The 5 factors to choosing a thermally conductive adhesive are thermal resistance, conductive strength of the adhesive, material thickness, substrate compatibility, and manufacturability. You should consider thermal resistance because it's a measurement of how that product can handle certain levels of heat. Depending on the product, it may be able to be better handling lower temperatures for a longer duration or higher temperatures for a shorter duration. It just depends on the material, which is why you have to consider thermal resistance. For instance, thermal pads, which are designed for high resistance, are able to facilitate the flow of heat from one substrate to another more easily. You should consider the conductive strength of the material because it's ultimately a measurement of how quickly that material can move heat from one side to the other. Typically, evaluating the material's conductive strength actually looks at the material itself rather than the adhesive. The material is usually going to dictate how well or how strong of the conductivity that it has. Conductive strength is also heavily influenced by the thickness of the material. The thicker the material is, the less efficiently the material will be able to transfer heat from one side to the other. Thicker materials tend to collect more heat at a slower rate, which isn't always ideal when you're considering thermal conductivity. Ultimately, you need to consider the substrate compatibility because that is what's going to drive the thermal conductivity. The actual thermal material needs to have a good connection to where it's transferring heat from and to where it's transferring heat to. For this reason, glues and epoxies tend to be limited because they can only connect to certain connections, whereas converters can take a thermal material, change out the adhesive on it, and make it suitable for more widespread applications. When it comes to electrical conductivity, we typically see thermal paste and grease because they're better suited for that particular application. However, when it comes to thermal conductivity, they may require an additional adhesive in order to be better suited for those internal components. Regardless of whether you're designing something for thermal conductivity, gaskets, or bonding, manufacturability needs to be at the forefront of your mind. It's one thing to create the best thermal management product in the world. However, it's a whole nother animal in order to make it manufacturable and cost effective. Simple application methods that are aligned with goals for both scalability and automation allow for more manufacturable processes that reduce costs and create production-friendly environments in the long run. To choose the best thermally conductive product, you need to consider these 5 factors in totality with your project and your specific needs. The only way to make the best decision is to consider these in relation to what you're trying to accomplish. If you need help with that decision-making process, an experienced converter can help guide you through those decisions as well as selecting the best product. When it comes to specific applications, it's important to choose the right materials and the right processes to ensure you get the best results possible. If you have any questions, feel free to check out our Learning Center or reach out to us directly. Thanks for watching.